Introduction to Decimal Number System and Decimal to Hexadecimal Conversion. We know that decimal number system is a base 10 system with 10 basic symbols 0 to 9, weights in power of 10, whereas hexadecimal number system is a base 16 system with 16 basic symbols 0 to 9 and A, B, C, D, E and F, weights in power of 16. With reference to the decimal or hexadecimal point, the power of base starts from 0 towards left and -1 towards right. Hence, in both the systems, the weight values increases as we move towards left and decreases as we move towards right. Out of 16, first 10 basic symbols of hexadecimal number system are same as used in decimal system, and the rest A to F are taken from English alphabets, which are equivalent to decimal numbers 0 to 15 shown in table. Here 10 in decimal system is equivalent to A in hexadecimal system. 11 is to B, 12 is to C, 13 is to D, 14 is to E and 15 is to F. It is most important to note here that the above decimal numbers are always to be replaced by equivalent hexadecimal digits, especially in case of decimal to hexadecimal conversion and vice versa. Now let us discuss about decimal to hexadecimal conversion. For decimal to hexadecimal conversion, the following two methods are used. For integers or whole numbers, the repeated division by 16. For fractional numbers, repeated multiplication by 16. And for mixed numbers, we have to perform the operations separately for integers and fractional parts and then combine together for the final result. Now let us consider example 1, where we have to convert decimal number 314 into hexadecimal number. It is an integer, so we have to perform the repeated division by 16 until quotient is 0. After first division operation, we get quotient equal to 19, remainder equal to 10. This 10 in decimal system is equivalent to A in hexadecimal system, which is the least significant digit here. After the second division operation, we get quotient equal to 1 and remainder equal to 3. This 3 in decimal system is also equal to the 3 in hexadecimal system. Now after the third division operation, we get quotient equal to 0 and the remainder equal to 1. This 1 in decimal system is also equal to 1 in hexadecimal system. Now this 1 is the most significant digit here. Now we have to read off. Hence 13A is the hexadecimal equivalent of decimal number 314. Now let us consider example 2. It is a fractional number. Hence we have to perform the repeated multiplication by 16. After the first multiplication operation, we get 10.50000. We have to take out the integer part 10, which is equivalent to A in hexadecimal system, and it is our MST. Next, the fractional part 0.50000 is to be multiplied by 16 again, and we will get 8.00000. The integer part 8 is to be taken out, and this 8 is equivalent to 8 in hexadecimal number system. The fractional part is 0 here, so 8 is the LST, and we have to follow the read down. So 0.A8 is the hexadecimal equivalent of the given decimal number. Now let us take example 3. It is an integer, so we have to perform the repeated division operation by 16. After the first division operation, we get quotient equal to 3023 and the remainder equal to 5. This 5 in decimal system is equal to the 5 in hexadecimal system. Next, this is our LSD here. After the second division operation, we get 188 as the quotient, and remainder is 15. This 15 in decimal system is equal to F in hexadecimal system. Next, after this operation, we get 11 as the quotient and the remainder as 12. This 12 in decimal system is equal to C in hexadecimal system. After this operation, we get the quotient equal to 0 and remainder equal to 11. This 11 in decimal system is equal to the B in hexadecimal system, and this B is the MST. Now we have to read off. So BCF5 is the hexadecimal equivalent of decimal number 48373. Next, let us consider example 4. It is a mixed number. So for the integer part, we have to perform the repeated division by 16, and for fractional part, we have to perform the repeated multiplication by 16 separately. For integer part, following the repeated division operation, we get this 14 in decimal system is equal to E in hexadecimal system, and in this case this remainder E is the LST, and for this the remainder is 1. This 1 is also equal to 1 in hexadecimal system, and for this 11 equal to B in hexadecimal system, and for this the remainder is 4, and this 4 in decimal system is also equal to 4 in hexadecimal system. Now After this operation we get the quotient equal to 0, so we have to stop here, and here the remainder is 10. This 10 in decimal system is equal to A in hexadecimal system, and it is our MST, and we have to follow the read off. So A4B1E is the hexadecimal equivalent of this decimal number 674590. Now for the fractional part, we have to perform the repeated multiplication by 16. If we perform the multiplication operation, then we get 12.50000, and we have to take out the integer part, that is 12. 12 in decimal system is equal to C in hexadecimal system, and it is our MST. Next we have to multiply the fractional part, that is 0.50000 by 16, and in this case we get 8.00000, and we have to take out the 8, and this 8 in decimal system is also equal to 8 in hexadecimal system, and since the fractional part is 0, this 8 is the LST. So we have to follow the read down, and here 0.C8 is the hexadecimal equivalent of the decimal number 0.78125. Hence A4B1E point C8 is the hexadecimal equivalent of the given decimal number. This is in brief about decimal to hexadecimal conversion, and for further details we have to continue to number system lecture 10. Thank you.